This is section 1.1, Inductive and Deductive Reasoning. As you will recall from the last video, inductive reasoning is the process of drawing conclusions based on experience, or in some cases patterns, and deductive reasoning is the process of drawing conclusions based on a general statement that you know to be true, otherwise known as facts. In this lesson, we're going to take a closer look at inductive and deductive reasoning in math. Let's look at this example. We're going to select a number, multiply it by 6, add 8 to the product, divide this sum by 2, and then subtract 4 from the quotient. Now we're going to apply this process to multiple numbers and repeat the procedure with as many numbers as necessary to make a conjecture about the result. Okay, let's do this. So let's pick a number first, and we'll go with the number 3. It's a small enough number, should be easy to work with. So we start with the number 3, and we multiply it by 6. So 3 times 6 is 18. Okay? Then we add 8 to 18. So 18 plus 8 gives us 26. Okay, then we divide this sum by 2. So 26 divided by 2 is 13, and then subtract 4 from the quotient, so 13 minus 4 is 9. Okay, so let's pick a second number. How about 5? No, let's do 6. It's an even number. 3 was odd, so let's go with an even number, so 6. 6 multiplied by 6 is 36. Add 8 to that product, so 36 plus 8 equals 44. Then we divide this sum by 2, so 44 divided by 2 is 22. And then subtract 4 from this quotient, so 22 minus 4 is 18. Okay, so we have 2 examples, and probably not enough to see any sort of pattern yet. Okay, let's pick a third number. We probably should go to somewhat of a bigger number instead of just working with small numbers. So how about 15? 15. Okay, multiply 15 times 6. Well, 15 times 6, we have 30, carry the 3, 6 and 3 is 9, 90. All right, add 8 to 90, so we have 90 plus 8, which is 98. Divide this sum by 2, so 98 divided by 2 would be, let's see, 45 and 45 is 90. We need 8, so 49. 49. And subtract 4 from this quotient, so 49 minus 4 is 45. Okay, so let's pause here, and let's see if we can draw any sort of conjecture between our original number and our resulting number. So we started with 3 and we ended with 9. We started with 6 and we ended with 18. We started with 15 and we ended with 45. Can you see any sort of pattern between the original number and the resulting number? You're right. The original number, in this case 3, is being multiplied by 3 to get 9. 6 times 3 gives us 18. 15 times 3 gives us 45. So we're starting to see a pattern here. So based on the pattern that we're seeing, based on the experience, based on inductive reasoning, we can make the conjecture that the process shown here will always result in the number that is 3 times the original number. So the process will always result in a number 3 times the original number. So there's our conjecture. Okay, now this conjecture uses inductive reasoning. It's based on the pattern that we've seen. All right, now we're going to use deductive reasoning. Notice that we're using the same process here, but what has changed is this very first step. Instead of using a number, we're going to use the variable n. Now remember that in algebra, a variable can stand for any number. That is a fact. Right? A variable can stand for any number. That is a fact. Okay, so here we go. Now, we actually don't even need this, because since n can stand for any number, we're not going to have to repeat this process more than once. Okay, so here we go. Let's use n, and we start with n, and we're going to multiply it by 6. So 6 times n is 6n. A little bit of algebra here. Add 8 to that product. So the product of 6n, we're going to add 8 to it. Well, you remember from algebra that a variable term with n and a constant term are not like terms, so we cannot combine those. So 6n plus 8 actually is 6n plus 8. Now, next step is divide this sum by 2. So 6n plus 8 divided by 2. We're dividing that sum, the whole thing, by 2. So again, using some algebra, you should remember that this 2 in the denominator applies to both terms in the numerator. So the first thing we have to do is we have to do 6n divided by 2. 6n divided by 2 gives us 3n. And then we're going to do 8 divided by 2, and we know 8 divided by 2 is 4. So in this case, we end up with 3n plus 4. All right, and then our final step in the process is to subtract 4 from the quotient. So we're going to do 3n plus 4, and then we subtract 4, so it's minus 4. Well, of course, the 4 minus 4 is 0, so this ends up giving us just 3n. Now, take a look at what we started with and what we ended with. Our original variable n can represent any number. So we finished with 3 times n. So what you see is, using inductive reasoning, we came up with a conjecture over here that was based on some examples. But of course, we only used 3 examples here. And 3 examples really isn't enough to have a solid conjecture that we can really be confident in. Right? However, when we use deductive reasoning, and the fact that a variable can stand for any number in algebra, we apply the same process, and now, having done just this one problem with algebra, we actually have tried every number possible. And we see that the conjecture is actually true. That if you take any number and apply this process, you will end up with a number that is 3 times the original number. This is actually the beauty of algebra. Algebra uses deductive reasoning because the theorems of algebra or the conclusions of algebra are based on facts. And as you can see, in one problem with deductive reasoning, we are 100% sure that this process will result in a number 3 times the original number. That's why algebra is so important. This concludes section 1.1 on inductive and deductive reasoning.